Here we're asked to add three fractions, 1/8, 1/4, and 1/10. To add fractions, we need like denominators. So in this case, we want to find the smallest common denominator that contains all three denominators, 8, 4, and 10. You can sometimes look at the three numbers and figure out what that is, but let's go through a process. Let's write the denominator 8 in factored form. That would be 2 cubed. Let's write 4 as 2 squared. And let's write 10 as 2 to the first times 5. The LCD is made up of the different bases, and the different bases are just 2 and 5. And then for the final step, we want to know the most time we see the base 2 in any one of the three places. The most we see it is 3 times, so that's the power. The most we see the 5 is once, so therefore the LCD is nothing more than 2 cubed, or 8 times 5, or 40. We now want to change each of the fractions over into equivalent fractions whose denominator is 40. Well, what times this denominator gives me 40? It would be 5. So we're going to multiply by one factor, 5 over 5. Therefore, the modified numerator becomes just 5. What times 4 gives me 40? That would be 10. So the one factor is 10 over 10. So the modified numerator would be 10. And this fraction multiplied by one factor would be 4 over 4. And the modified numerator would be 4. Now, to add fractions which all have the same denominator, we keep the denominator and we add the numerators. 5 plus 10 is 15, plus 4 is 19. That is the addition of the fractions, which cannot be reduced or simplified any further. So we are finished. Here we are asked to add two mixed numbers, 8 1/3 and 5 7/8. I find it easiest and to work with smaller numbers, but by adding these vertically rather than horizontally. So 8 1/3. Underneath it, I'm going to put 5 7/8. And I want to add. Well, I only want to deal with the fractions first rather than the whole numbers. So I need to convert the fractions to like denominators, which would be 24. And 8 times 3 is 24, so we need to multiply the numerator also by 8. And 3 times 8 is 24, so we need to multiply the numerator by 3, that's 21. Now we are able to add the fractions, keep the denominator 24, and add the numerators. 8 and 21 would be 29 24ths. Notice that this is an improper fraction, so let's convert this to a mixed number, which is 1, and take away 24 from 29, has a leftover of 5 24ths. Let's go back now. We need to add the whole numbers. 5 and 8 is 13. And to get the final result, we add the whole number result to the mixed number result, which is going to give me 14 and 5 24ths. Now, if this question allows mixed numbers, then we are done. If it says it wants does not allow mixed numbers, we would have to then take 24 and multiply it by 14, add 5 to it, and then divide it by 24. Let me do that on my calculator. So 24 times 14, add 5, and that would be 341 over 24. So as an improper fraction, this is the answer, and as a mixed number, this is the answer. This is a very interesting problem, and it was very challenging to me when I first saw it. It says, because of evaporation, a pond loses 1/13 of its remaining water each month of the summer. If it is full at the beginning of the summer, what fraction of the original amount will the pond contain after 3 months? Well, let's draw a picture. Here is a pond, and I'm making it circular, and it's full. So full means one unit. I'm going to evaporate 1/13. So if I evaporate 1/13 from a whole, I am left with 1 minus 1/13, or 12/13. So at the end of the first month, we have 12/13 less. So we have less water. Let's still make it round, but a smaller circle, which is all of the water that remains. And that circle is one whole unit. We're going to evaporate 1/13 of that circle. So we evaporate 1/13, we're taking 1/13 away from a whole circle. We are left with 12/13 of the smallest circle during the second month. Let's make another circle that's even smaller because we have less water. And that's one whole circle, but we're going to evaporate 1/13 of it. So if we take 1/13 away, we have 12/13 of the smallest circle left at the third month. And it says, what fraction of the original amount will the pond contain after 3 months? Well, it has 12/13 of the smallest circle, which is 12/13 of the middle circle, which is 12/13 of the original circle. So the amount left at the end of 3 months is just nothing more than 12/13 times 12/13 times 12/13. And if we multiply those together, which I'm going to do, 12 times 12 times 12, which is 1728. And then I'm going to multiply 13 times 13 times 13, which is 2197. So that's how much of the original circle is left at the end of 3 months.